Okay, hello class. In the last sessions, we talk about structure. In these sessions, we will learn class, which is a very important concept in object-oriented programming. So let's start. So what is class? Class is similar to structure because like structure, it can have member variables. But unlike structure, class can have member functions as well. So this is a concrete example of class. Instead of using struct keyword, you use class keyword to define class. Day of year, this is the name of the class. And like structure definitions, you can declare member variables. Here, months and day are the member variables of day of class. And here you can define member functions like this. Class definitions, so we call these class definitions, normally only contains the declarations of the member functions. So, and the actual implementation of the member function is given in different locations in the source code. So here we only put function declarations and with semicolon. No implementation of this function is given here. And we will talk about public keywords in the following sessions. In this session, we focus how to define classes and create objects syntactically. So class is a key concept in object-oriented programming paradigm, and member functions defines the behavior of the objects, and the member variables defines the data of the objects. So then what is the relationship between class and objects? You can think that class is a blueprint or templates of objects, and object is actual instance of the class. So if you look at this example, class, this is just templates for making car. It is not concrete thing. It does not have value or data. It's just templates. On the other hand, using these class templates, car class, if you make real car, such as a Mercedes, BMW, and Audi, then these are the objects of this car class, because these objects are created based on this class. So unlike class, object is concrete thing. It has a value or data. So this is a very important concepts in OOP. So let me summarize them again. In summary, class is a template for defining or creating objects. So class defines object properties such as a name and types of member variables and behaviors of the object through member functions. Because class is templates, it is not concrete thing. It does not have any values or data. And object is an instance of the class. So it is created based on the class templates. And because it is concrete thing, it has values and data. So that is the relationship between class and objects and the differences between class and objects. Then how can we create object from class in C++? To create object from class, you specify class name and followed by the object name. So if you look at this example, we have already defined day of year class in previous slides. You can create objects of day of year class like this statements. You specify class name and then put the object name here. Here we declared two objects of day of year class, today and birthday. If you declare it, object will be created. And as I explained in the previous slides, object is instance of class and it is concrete thing. So it holds data in member variables and its behaviors are given in the member functions defined in the class definitions. So object includes data and operations. The member variables of the objects can be accessed via dot operator, which is this one. The same way you access member variable in the structure. So today is an objects of day of year class that we defined in previous slides. Using this dot operator like this, we can access months and day member variable of this object. And you can also call member functions of the object using dot operator like this one. We are calling output member functions of this today object. And there is something called scope resolution operator, which is 2 colon with no space between them. We use dot with object and scope resolution operator with class name. So for example, we used scope resolution operator here. I said that we usually only put the function declarations inside of the class definitions like this. No actual implementations are defined in these class definitions. It's just function declarations, and write function definitions outside of the class definitions like this. So function definition starts here and ends here with semicolon. This is not part of the function, class definitions. So we usually put the implementations of member functions such as output in this example. We put the implementations of member function outside of the class definition like this. And when you're defining member functions, you must specify the class name using scope resolution operator like this. So because output function is from this day of year class, we put day of year class name here using a scope resolution operator. This is required because there might be the same name of member functions from 2 or more classes. So you have to specify class name before the member functions to tell compiler which class the functions belong to. Otherwise, compiler error will occur. And sometimes member function itself wants to access the member variables of the object. So day of year class has two member variable, month and day. As you can see here, this class has a two member variable, day and month. And if this output member functions wants to access the values of these two member variable in the actual objects, this pointer should be used. This pointer is predefined pointer. It is automatically defined by the C++ compiler. And this arrow symbol is a dereference operator, which is same as in C when you are using a pointer. Using this pointer, you can dereference the objects of being used to call these member functions. So assume that object 1 is objects of day of year class. So if we call this output member function using this object 1 through dot operators, this function call statement is converted to something like this one by the C++ compiler automatically. So as you can see here, the address of this object 1 is passed to the member function's output as a first argument. So this object's address is passed to this output's first argument like this one. Then C++ compiler also convert these function signatures to something like this one. The class type of pointer name, this is automatically added to the function signature as a first argument. So you can think that this pointer here is passed as hidden arguments when you are calling member functions. And using this pointer, you can dereference the values of member variables in the objects because this is the pointer which points to the objects. Here, using this pointer, it is dereference the member variable month and day. So with this, you can access the member variables of object 1 inside of member functions like this. And there is a scope conflict. As you can see here, these are the member variable, month and day. But the parameter name of this assign function is also month and day. So the parameter name is same as the member variable's name. So there is a conflictions. But if you use this pointer here, C++ automatically refer this month as a C++ think this month as a member variables, not the parameters. So if you put this pointer, you references the member variables, and this one, month and day, is a parameter of these functions. So member function parameter has the same name. We can only access the data member using this pointer. So let's look at the demo code quickly. So this is a demo code for the class. Let me make the font size larger. As you can see here, there is a class definitions. The class name is a day of year, and class definition start with a class keywords. And it has a member function output, assign one, and let me delete assign three, assign one and assign two. And it has two member variables, month and day. And as I said in the previous slide, we only put the function declaration inside of these class definitions. And we do not actually put the actual function implementations like this. We only put the function declarations. And then we put the function definition outside of these class definitions. Here we put the function definitions of assign one and assign two and output here. And note that we use the scope resolution operator, double colon, and the class name to specify which class these functions belong to. So these three functions are all belonging to day of year class. The output function is very simple. It's just print month and day member variables. And assign one function set the member variable month and day using these two parameters. And assign one also set the member variable month and day using this parameter. But the difference between these two functions is that this function uses this pointer, and this function does not use this pointer. Even though you do not explicitly put this pointer here, C++ automatically puts this pointer here. So the results of this assign one function should be same as assign two functions. And inside of main functions, we declare the objects of day of year class. So object is created here. And we set the member variables of these objects, month and day, using a dot operator, 5 and 11 here, and then call the member function output. So if I compile this program and run it, as you can see here, because I set the month 5 and day as 11, the program prints 5 and 11. And this one, I use the member function assign one to set the month and day, like this one. So because month is set to 9 and day is set to 6, this prints 9 and 6. And similarly, assign two functions also set the month 1 and day to 22 because of this one. And if I print it using a member function output, it's printing 1 and 22. So this is how you define class and define member functions and create the object of the class and access the member variables and member functions. And if I omit the class name here, for example, if I only put this one and compile it, it gives a compiler error because it cannot find the month and day. Undeclared identifier month, undeclared identifier day. This is the compiler error. So compiler cannot find month and day. That's because these functions, we did not tell these functions is belonging to day of year class. And month and day are the member variables of day of year class. And because this function is not belonging to this class, compiler cannot find month and day here. So you have to specify the function, class name here. Okay, so let's go back to the slides. Okay, this is the example we saw just now. So this is the complete class example from the textbook. Here is a class definitions. Like previous demo code, its class name is a day of year and has a member functions output and member variable month and day. And inside of the main, it creates the two objects of this day of year class, today and birthday. And then it sets the months and day member variables for the today objects. And it also set the months and day member variable for the birthday object as well, like this. And then prints the months and day of today objects and birthday objects through member function named outputs. So, and the output member functions are defined like this one. As you can see here, only the function declarations are included in these class definitions, and actual these function definitions are outside of these class definitions. So this is the function definition of output member functions. And based on, depending on this month, which is a member variable, it prints different values. It prints the month with a string. And then it prints the day. So if I enter month 10, day of month 15 for today's objects, and if I put 2 and 21 for the birthday objects, and then this program prints the October 15 for today's objects values, which is 10 and 15, and also prints the February then 21 because I put 2 here and 21 here for the birthday objects. Okay, so let me conclude today's sessions. So in this session, we learned how to define class and create object syntactically in C++. And in the next video, we will learn more about classes and objects, why we should use class, and how to design good class. We will talk about these things in the following sessions. So see you in the following sessions.